So in the last session, we started the session with basics of networking, right? So in basics of networking, we discussed about what is network, what is networking, types of networks, and what is the advantage of connecting the devices into a network. Okay, and what is what are the types we have in network that we discussed in the last session. Network means when two or more devices are connected physically, then it is called network, right? When they are communicating with each other with the help of IP address, then it is called networking. As we discussed, if two devices wants to communicate with each other, compulsory they require physical connectivity and logical connectivity, right? So physically and logically devices are connected with each other, they can share the resources, that is called networking. And what is the advantage of connecting the devices together? Means we can share the resources. If one PC is connected to another one, we can share the resources, hardware and software we can share from one device to another device. Right. So we have types in network like local area network, metropolitan area network, and wide area network. The devices which are connected within a campus or building that we call as local area network. The devices which are connected within a city and communicating with each other, we call it as metropolitan area network. And the devices which are communicating between different geographical areas that we call as wide area network, right? So next topic is, this is what we discussed in our last session. And now basic requirements to form a network. You want to establish your own network. Okay, so you want to establish your own network. Like assume you have it 2-3 pieces in your home. Maybe you have laptops or desktop, or you are staying at hostels or room with your friends. So you all have the laptops. You want to establish your own network just for practice purpose. You want to establish your own network, or you are starting a startup company, so you want to establish a network. So what are the basic requirements to establish a network? Means, so these are the basic requirements: NIC, media, networking devices, topology, IP address, and protocols. These are the basic requirements to connect our system in a network. Okay. So first one is NIC. These are the basic requirements. The first one is NIC, Network Interface Card. So while manufacturing of NIC, a MAC address is hard-coded in it, means fixed in it. While manufacturing of NIC, a MAC address is hard-coded, fixed in it. What is MAC address? Means it is the physical address of our system in a network. MAC address is a physical address of our system in a network. Why it is called physical address? Because it comes along with your device, with your laptop or desktop. That is why it is called physical address. MAC stands for Media Access Control. What is MAC address? It is a physical address of our system in a network. See, in our laptop or desktop, you can see LAN cards, LAN ports, Ethernet ports, or internet ports. We may call it different names. We can see the port, right? If you want to take internet connection, if you there you can see in our CPU RJ45 port, right? So what I'm talking is about that only. So while manufacturing of NIC, that port, in technical terminology, we call it as network interface card. Okay, so while manufacturing of that interface, a MAC address is hard-coded in it, fixed in it. What is MAC address? Means it is a physical address of our system in a network. Why MAC address is called physical address? Because it comes along with our device, with our LAN card only. That is why it is called physical address. Okay, and it is unique address. It means from one NIC to another NIC, they will change the MAC address. That is why it is a unique address. No two NICs in this world will have the same MAC address. So it is a physical address. And MAC address comes with 48-bit binary or 12-digit hexadecimal form. MAC address comes with 48-bit binary or 12-digit hexadecimal form. Forty-eight bit binaries means like this. 01 binary form, you will get in 48 bits, or 12-digit hexadecimal. Hexadecimal means what? Combination of alphabets and numerical. 16-bit hexadecimal, 16 digits with the combination of alphabets and numerical. So, for example, A, B, C, D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From here, A, B, C, D, E, F. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. 0 to F, 16. So, what either 48-bit binary or 12-digit hexadecimal. 12-digit hexadecimal example 00, 1A, 2B, 4C, 881. You'll get like this. Okay, so here half digits. It may be 48-bit binary or 12-digit hexadecimal form. Half digits represent vendor ID. Half digits represent vendor ID. Vendor ID is constant. First 6 digits are constant because they are vendor ID. Vendor ID means a company code, company idea, that is. If one company release 1 lakh NICs also, for all the NICs, the first 6 digits are constant, same. And the last 6 digits represents card ID. Card ID means MAC address. The last 6 digits are different from one NIC to another NIC because the last 6 digits are card ID. Card ID means MAC address. MAC address is unique address. So our MAC address we get with 48-bit binary or 12-digit hexadecimal form. Okay, so that is about NIC. I'm repeating NIC. While manufacturing of NIC, a MAC address is hard-coded in it. It is a physical address of our system in a network. Okay, MAC address comes with 48-bit binary or 12-digit hexadecimal form. MAC and NIC means this LAN port. We are talking about this card. This card you will get with different speeds like Ethernet, fast Ethernet, gigabit Ethernet cards you will get. What is the difference between Ethernet, fast Ethernet, gigabit Ethernet? Means speed is different. Ethernet is with 10 Mbps, fast Ethernet with 100 Mbps, and gigabit Ethernet is 1000 Mbps. Is this clear, everyone?
Madam, I have a doubt here.
What is MAC address? It is a physical address of our system in a network. Okay, why it is called physical address? Because it comes along with our NIC. It is fixed in our computer. That is why it is called physical address. And it is unique also. From one NIC to another NIC, MAC address is different. That is why it is unique address. Is this clear, everyone? Yeah.
Madam, am I audible?
Yeah, now audible, Venkatesh.
Madam, I have a doubt here. Out of the 12-digit hexadecimal, if the first 6 digits represents vendor ID and the next 6 digits represent card ID, and you said that no two MAC addresses will have this same ID, they are unique. So based on the card ID 6 digits, is it possible that the vendor may manufacture many devices and these 6 digits may not be sufficient number, maybe the number crosses the limit?
No, they can change more.
To what extent these digits are applicable? I mean, to what number extent? Like, is it for up to 1 lakh device or up to 10 lakh devices? After that, the number, what would be happen with the number with the 6 digits?
Okay. Zeros and ones are there, binary conversion, 6 characters, and with alphabetics up to F. This conversion I will show you. So, one sample example I will give you. In next, after this, you'll get understand how many IP, how many MAC addresses you will get for one company. That I will show you sample example.
Yeah, that is my question is how many MAC addresses can a company
Yes,
provide
that,
using
that I will
6
that I will
digits?
explain. As of now, this is clear, right?
Yeah, this is clear, right?
Yeah. So the next basic requirement is median. Data transfer takes place through media. So in media, we have two types, guided media, unguided media. Media, we have two types, guided media, unguided media. Guided media means there is a specific direction to transfer data. In guided media, there is a specific direction to transfer the data from source to destination. Unguided media means it will transfer the data from source to destination, but it will not maintain any specific direction in unguided media. I'm repeating, in guided media, there is a specific direction to transfer the data from source to destination. Okay, so unguided media, it will transfer the data, but it will not maintain any specific direction to transfer the data. Okay, so can anyone tell what is the example for guided media?
Internet through cables, Ethernet cables.
Exactly. Example for guided media is cable. Because when we are using cable connection from one device to another device, using which path we connected the device, using which cable we connected the device, it will transfer the data through that path only. So example for guided media is cable. Cables means we have cables like coaxial cable, twisted pair cable, fiber optic cables. In cables, we have coaxial cable, twisted pair cable, fiber optic cable. At present, coaxial cables are outdated. We are not using coaxial cables. Okay, twisted pair cable and fiber optic cables are available. So guided media, unguided media. Media, we have two types, guided media and guided media. Guided media, there is a specific direction to transfer the data. Unguided media, no specific direction to transfer the data. Okay, so as I told, example for guided media is cables, coaxial cable, twisted pair cable, or fiber optic cables. At present, coaxial cables are outdated. Twisted pair cable and fiber optic cables are available. An example for unguided media is wireless connectivity. Because when you are using wireless connection, it transfers the data from source to destination, but it will not maintain any specific direction. Through radio frequency waves, from where the signals are coming, through that way only it will transfer the data. It will not maintain any specific directions. That is why example for unguided media is media. Media we have like Bluetooth, infrared, Wi-Fi connection, RF waves, radio frequency waves. This all comes under unguided media only. Examples. Okay. So these are the cables we have. Coaxial cable. In cables we have coaxial cable, twisted pair cable, and fiber optic cables. Yeah. One more point I want to tell you is in twisted pair cable, we have two types. In twisted pair cable, there are two types, UTP and SDP. Unshielded twisted pair and shielded twisted pair. There are two types of cables. Unshielded twisted pair and shielded twisted pair. Unshielded twisted pair means there is a specific it transfers the data from source to destination. There is a specific direction and it is low cost. UTP cables are low cost. Generally, in home and office PCs, we go with UTP cables only. It is low cost. And STP cables, they are high in cost. This is also used for same purpose, but they are high in cost. What is the difference between UTP and STP? Means STP shielded twisted pair. If you open outer jacket of STP cable, inside we can find one cover, plastic cover. It is also called plastic shield or mesh. Technically, we call it as plastic shield or mesh. It is used to reduce electromagnetic inductions, means disturbances. Where we are getting more disturbance to transfer the data while sending and receiving, in that places they go with STP cable. For general purpose, we use UTP cables only. Okay, so in cable, we have twisted pair cable, fiber optic cable. In twisted pair cable, we have UTP, STP. UTP unshielded twisted pair, STP shielded twisted pair. Okay. I'm already preparing the notes. I will share the notes.
Then will you share the PPTs as well?
PPT I will not share, but everything, notes is there. I already prepared the notes completely.
But since your PPTs are with images, that would be helpful for easy understanding. That's what I asked.
PPTs we don't share. If you want, you can take screenshot. So, unshielded twisted pair and shielded twisted pair. So, in shielded twisted pair, there is a plastic shield, how we call it as mesh, to reduce electromagnetic inductions. Okay, in cables, we have categories. In our twisted pair cable, we have categories like Cat1, Cat2, Cat3, Cat4, Cat5, Cat5e cables are there. Cat1 cable is used for telephone, black color wires. So those are telephone wires. Cat2 to Cat6 are used for networking connection, but at present Cat2 and Cat3 also we are using for network connectivities. Difference between these cables or speed. Data transfer rate speed is different. Okay, so and if you open outer jacket of this Cat1 cable, inside we can see two pairs of wires. Two pairs means while twisting they will give two pairs. If you remove the twist means there you will get four wires. In Cat2 to Cat3 cables will get four pairs of wires while twisting. If you remove the twist means you will get 8 wires. At present we are using Cat5, Cat5e, Cat6 cables we are using in market. Okay, so connector for Cat1 cable is RJ11. If you see landline connection, there you can see small pin. That pin name is RJ11. And connector for Cat2 to Cat6 is RJ45, registered jack 45. In our internet connections, if you're giving to CPU means you can see one small connector, right? The connector name is RJ45. RJ11 and RJ45 both look same only. Then what is the difference between RJ11 and RJ45 means number of pins. RJ11 with 4 pins, RJ45 is with 8 pins. And connecting RJ45 with cat cables we use tool. The tool name is crimping tool. Right? In cables we have.
Can you show us the image, madam, once? I'll take a screenshot.
Thanks. Right. So these are the cables. While twisting, they will give 4 pairs of wires. If you remove the twist, you'll get 8 wires.
Okay, madam. What is the use of coaxial cable?
Coaxial cable at present we are not using. It is outdated. Only in bus topology, we used to use coaxial cable. The topology is outdated. This cable also outdated. It is not at all available in market. No one are using this cable. That is used only in bus topology, which is outdated. The topology we are not using, bus topology. Okay, so in the cables we have two types, straight cable and cross cable. Straight cable is used for connecting dissimilar devices like PC to switch, PC to router, switch to router, PC to hub, or switch to router, switch to hub. If you want to connect means we go with straight cable. When you want to connect to similar devices like PC to PC, hub to hub, switch to switch, we go with cross cable. Okay, so in cables we have two types, straight cable and cross cable. My voice is audible? My voice
Yes,
is audible?
yes, you are audible.
Yes, ma'am.
Okay. So straight cable and cross cable. Straight cable is used for dissimilar devices. Cross cable is used for similar devices. PC to PC, hub to hub, switch to switch, even PC to router. If you want to connect also, we go with cross cable. Cable connections, practically I will show in further sessions. As
Can
I
you come
told you
again,
already,
madam? Straight cable is used for?
dissimilar devices, different type of devices like PC to switch, PC to hub, switch to router, switch to hub. We go with straight cable. Cross cable is used for similar devices like PC to PC, switch to switch, hub to hub. Even PC to router also we go with cross cable. And this cable connection, practically I will show in further classes. Practical also I'll show how we connect these cables. Okay, and I told you again, I'm telling this is only basic classes, just introduction class, brief information about the network connectivities. Everything in further classes will discuss completely in depth. Will discuss practical along with practicals. This is only basic information what I am giving, like introduction. Okay, so we have cables, tight cable and cross cable. So how to find which is tight cable and which is cross cable means by color coding. Straight cable and cross cable we can find by using the color coding. This is the color coding for straight cable. 8 wires. Both side color is same. Both side we use same color coding for straight cable. Okay. And coming to cross cable, in cross cable 1, 3, 2, 6, colors are changing. In one end, what is the first color coding of the cable? That goes to third position. Second color goes to sixth position that I mentioned here already. So both sides same color coding is there means that is straight cable. So from one end to other end color coding is changing means that is cross cable. Okay, we also have another cable that is rollover cable or we call it as console cable. It is used for initial configuration of a router. When we purchased a new router, we do some configuration in that router with the help of this console cable. Okay, so in the console cable, color coding, one end is same like straight or cross cable, other end is in reverse order. That's it. At present, we are not making these cables. So we are getting these cables in network shops. By default, we are getting, they are making and they are giving these cables. But still, we should know the color coding for troubleshooting purpose. Next one is topology. Physical layout of our system in a network. Topology means we have different topologies. And before discussing about topologies, networking devices, hubs, bridges, switches, routers, this all comes under networking devices. Okay. So in topology, it is a physical layout of our system in a network. Topology means physical layout of our system in a network. Okay. So we have different topologies at present. One moment. In this topology, they will use coaxial cable. Using coaxial cable, they will give the connections. For a single cable, they will connect the PCs. By using only one cable, single cable, they will connect the pieces. Example, assume these are my pieces which are connected to my coaxial cable. So in coaxial cable, topology, physical layout of a system in a network. Okay, we have different topologies. First one is bus topology. In bus topology, using single cable, they will connect all the devices. Okay, if any problem occurs with a cable or a device, entire network will go down. That is in bus topology. Here, transmission type is broadcasting. We have three types of transmissions: broadcasting, multicast, unicast. Transmission type is three types: broadcast, multicast, unicast. Broadcast means one to all, like news channels, uh, radios, newspapers. This all comes under broadcasting devices. So in broadcasting, if one device is sending the data, remaining devices will receive the data. Okay, so that is broadcasting. And multicasting means one to a specific group, like server to clients. If one server is sending any data, devices which are connected to the server, all the devices can receive the data. That is multicasting. Unicast means one to one, like PC to PC. Okay, so I'm repeating. So transmission type is three types: broadcast, multicast, unicast. Broadcast means one to all, multicast means one to a specific group, and unicast means one to one. In bus topology, transmission type is broadcast, one to all. That is also problem here. If one PC want to transfer the data to a particular PC also, it will send the data to all the PCs in a network. That is one problem. And the major problem is, if any problem occurs with a cable or a device, entire network will go down. That is the main problem of bus topology. So this topology is outdated, and this cable also outdated. Coaxial cable also outdated. We have another topology, that is ring topology. In ring topology also, using single cable only, they will connect all the devices. All the devices, they will connect to only one cable. All the devices are connected to single cable. Okay, here in anti-clock direction, it transfers the data. It transfers the data in anti-clock direction, like this. So example, this is A, PC A. This is my PC B. If A PC want to transfer the data to B PC, first it will send the request to ring. Okay. Now what this ring topology will do? It transfers the data to D, D to C, then B. Okay. If A want to transfer the data to C, it transfers the data to D, D to C, like that. So it transfers the data. In middle, how many pieces are there? For all the pieces, it transfers the data. This problem. No security for the data. Okay. And another problem is, using single cable, they connected the devices. So if any problem occurs with a cable or the device, entire network will go down here also. And ring topology, it can do only one task at a time. If A want to transfer the data to CPC, it will send the request to ring topology. So it will take one token. Okay, when the ring is sending the data, in the same time, it cannot receive the request token from any other pieces. That is the problem here. So this topology is also outdated. We are not using ring topology also. Okay, so we have another topology, that is star topology. In star topology, hub and switch are the centralized controllers. Hub and switch are the centralized controllers in star topology. Okay, so in star topology, how it will do the function means, now assume, as I told, hub and switch are the centralized controllers in star topology. Now assume this is your hub. These all pieces are connected to your hub. Okay, here, using individual cables, these are twisted pair cables. Using individual cables, they connected all the devices. So if any problem occurs with a cable or a device, it will not affect to other devices in a network. That is the advantage of hub. Using individual cables, the devices are connected. So if any problem occurs with a cable or a device, it will not affect to other devices in a network. But the problem with hub topology, it broadcasts the data. If A want to transfer the data to B system, A system will send the request to hub. Like my system is A, I want to transfer the data to B. But what this hub will do, it will broadcast the data. It will transfer the data to all the pieces which are connected to this network. So the disadvantage or disadvantage means disadvantage only, because this PC want to transfer the data to a particular PC, but it is broadcasting the data. That is the disadvantage here. Okay, another disadvantage is it shares the bandwidth. Now here, you have 128 Mbps speed. Two PCs are there, means 64, it shares the bandwidth. If 4 PCs are there, 32, 32, 32, 32. If 6 PCs are there, 16, 16, 16, 16, 16, 16, like that. Or 8, 8, 8, 8. It depends on number of pieces you have. It shares the bandwidth. That is also problem here. And one more thing, hub can do only one task at a time. If A is sending the data to B, in the same time B cannot transfer the data to A or C or any other PC. It can do only one task at a time. That is also problem here. What is the advantage? Means using individual cables, they connected the devices. So if any problem occurs with a cable or a device, it will not affect to other devices in a network. And this low cost device. So if your requirement is not security, you just want one centralized controller, we can go with hub.
What is this topology called, madam? Star topology.
Star topology.
STAR, right?
Star. STAR, star.
Okay, got it.
In star topology, second one is switch. Switch is a centralized controller in star topology. Okay, so in switch also, using individual cables only, all the devices are connected with each other. So if any problem occurs with a cable or a device, it will not affect to other devices in the network. That advantage is here also. For the first time, if A want to transfer the data to B system, here also A system will send the request to switch. Like my system is A. So for example, one want to transfer the data to system 2. So first system will send the request to switch. Like my system is 1, I want to transfer the data to 2. Now what switch will do is it will broadcast the data. Okay, and while broadcasting the data, it will take each and every system MAC address and it will store that MAC addresses in MAC table. When first PC send the request to switch, immediately that first PC IP MAC address it will store in MAC table. What is MAC table? What is MAC address? It is a physical address of our system in a network, right? So MAC table is used to store MAC address. MAC table is inbuilt in our switch. Remember, switch is an intelligent device because it can store MAC addresses. Okay. So for the first time, if one PC want to transfer the data to another PC, if S want to transfer the data to D, it will send the request to switch. Like my system is S, I want to transfer the data to D. Immediately, switch will store a system MAC address in MAC table. Okay, so then it will broadcast the data. It transfers the data to all the pieces which are connected to this switch. When S system S send the request, immediately it will store that system MAC address in MAC table. And then what it will do is it will broadcast the data to all the pieces except to this A source PC. Except to this source PC, it will send the request to, data to all the pieces which are connected into this switch. While broadcasting, it will take each and every system MAC address and it will store that MAC address in MAC table. All the systems addresses it will store in MAC table. Second time, if APC want to transfer the data to, if system 1 want to transfer the data to system 3, system 1 will send the request to switch. Now what switch will do is, first it will check in MAC table. For particular system 3 only, it will transfer the data. because now switch knows which is A, which is B, which is C, which is D, like that, because in MAC address it is maintaining that information. Okay, only one time switch will broadcast the data. While broadcasting the data, it will take each and every system MAC address and it will store that MAC addresses in MAC table. And second time onwards, when any PC want to transfer the data to other PC, it will check the MAC addresses. And for particular PC only, it will transfer the data. Means it will unicast the data from second time onwards. So first time only it is broadcasting. From second time onwards, it is unicasting the data. So it is intelligent device. And we have security also, because individually it transfers the data from second time onwards. Here also using individual cables, they connected the devices. So that is also advantage. And it doesn't share the bandwidth. Individual same speed it transfers to all the devices. That is also advantage. Switch you can do multitasking at a time. Switch can do multitasking at a time. So that is also advantage of switch. So comparing to hub, there is a disadvantage in switch. That too, if you compare with hub, that is, it is high cost device comparing to hub. But if our requirement is security, we don't bother about cost. So we'll go with switches only. At present, for connecting pieces, we are using switches only. Okay, so this is just very brief introduction I'm giving. In switches, we have so many configuration, different types of switches are there. Okay, so we have separate concepts of switching. Almost 1 week classes are there for switching. At that time, completely I will explain about switches. This is just information. That's it. We have another networking device, that is router. So router is a layer 3 device. What is this layer 3, layer 2, layer 1 resolve? In OSLAS, I mean, in our next session, I will explain. Okay, it is an intelligent device because switch contain routing table. It stores all the source addresses, destination addresses in that routing table. It works with logical address. It works with IP address. Okay, and it maintains the fixed bandwidth. And what is this router means? Router is a networking device which gives communication between two or more different networks. And router is also responsible to transfer the data using best path. Okay, and about this routing, about this router, in our further classes, I will show you practically. We have separate classes for this. 15 days almost classes are there. Okay, so what is this broadcast domains, collision domains? I'll explain in that classes. Okay. So these are the basic router is, and one more point, router is not basic requirement. When your network wants to communicate with another network, then only we need a route. Our requirement is up to this only, up to centralized controller only. Router is a networking device. That is why we mentioned router here. But what is the use of router means? When your network wants to communicate with another network, we need a route. Okay, but as of now, our requirement is we just want to establish a network. So router is not required. Okay, so about that completely we'll discuss in our further session. And the next basic requirement to connect our system in a network is protocol. Protocol means set of rules for communication. About protocol in tomorrow's session we'll discuss as OSI layers. Using OSLAS, we'll discuss about protocol. But OSLAS is not a brief class. The complete OSLAS I will explain. Okay, complete OSLAs I'll explain. It will take 1 or 2 days, not 1 day. Compulsory it will take 2 days. I'll explain completely OSLAs. Okay, so this is for today's session, and tomorrow we'll start the session with OSLAs. Anything you want to ask?
Yes, madam. Hello.
Venkatesh.
Madam, since I'm non-technical, I just have a basic doubts. Please don't mind.
Yeah, sure.
You said that functions of switch for the initial first time, if D wants to communicate to S, it will ask the switch that I want to communicate to this MAC address. So how does the D know about the MAC address of the S?
Not
First
MAC
thing.
address. IP.
Okay.
It will send with IP address. PC
Sorry.
transfers the data to IP address.
Okay, IP
So
address.
switch
How does the D know the
doesn't
Hello?
Yes, ask Venkatesh.
Yes, ma'am. How does the D know the IP address of S? That's what my question.
Yeah, sharing, that is again different concept.
Okay.
IP addresses are assigned to all the PCs, right?
Mm-hmm.
With the help of IP addresses, only PCs will communicate with each other in a network.
Okay.
So actually, employees don't know the IP addresses of the PC.
Mm-hmm.
But what administrators will do is, instead of giving IP addresses, they will tell every employee's user IDs. They will. We have an application. If you just click on that employee's username, means it connects to their IP address.
Okay. Got it. So that means
Employees
if we...
don't know any one IP address. If you just
Mm-hmm.
click on that username, means it will connect to that IP.
Mm-hmm.
So, but switch doesn't know the IP addresses, right? It will broadcast the data. It will check each and every system MAC addresses. It will store that MAC addresses in MAC table. So next
Okay.
time, when any PC want to transfer the data, first MAC address will switch will check in MAC table which PC is related to that MAC address. That particular PC will transfer the data.
How long this switch maintain this MAC address table, madam?
Yes,
Because
yes.
initially...
Switch is see, even in some interviews they'll ask why switch is an intelligent device or what is switch. Switch is an intelligent device. Why it is called intelligent device? Because it contains MAC table. MAC table is inbuilt. What is
How
the
long
use
it
of
will...
MAC?
How long it does
Yeah,
hold, madam, actually?
yeah. How long?
It
It
will
will be
hold
hold
the... Uh,
until we restart the switch.
until we restart the switch, that will maintain the table. Okay.
Yes. If you restarted the switch means again it will broadcast one time, from second time onwards it will unicast.
Okay. If we add any new device to the network, then
Hmm.
also the MAC table gets restarted, or it will just add another
If,
row.
yeah, we'll do broadcast again.
Okay.
Whenever you restart the switch, we restart it, we switch off or switch on, we switch on. Or if
Mm-hmm.
anything is connected newly,
Mm-hmm.
it will broadcast.
Okay. Got it. That cleared my doubt.
So in tomorrow's class, I'll explain about OSLAS. So this is for today's session. Thank you for the session.